I think building a clean energy park in Pueblo County, one that includes a nuclear power plant, is a good idea for our community. It would be impossible to create a park using just wind, solar, geothermal, biomass alone. And the reason is you couldn't afford the infrastructure that would be necessary on this land, as far out as it is, to support these other forms of energy. So some people have suggested drop the nuclear and do just wind and solar, and I'm saying it can't economically be done. I'm proposing the use of wind and solar as well as nuclear, but I'm going to focus my remarks tonight on the nuclear aspect of the project, since without a clean energy park won't happen. I think this is a good idea for our county because nuclear energy is safe, it's clean, it's efficient, and it generates electricity at the lowest production cost, lower than coal, gas, fuel, lower than oil, lower than wind, lower than solar. It's safe because nuclear power plants have the highest standard of safety in the energy producing industry. No other industry is as closely regulated or monitored. And I'm sure my opponents are going to bring to you lists of hazards that have happened at the various nuclear power plants in America over the last 50 years. The only reason they can do that is because the nuclear power industry posts on the web everything that ever happens in a nuclear power plant. Everything. A fire that has nothing to do with nuclear fuel is reported on the website, and it's on that list. Somebody has an accident in the nuclear power plant. That too is on that site. Everybody in the world knows everything that happens inside a nuclear power plant in the United States of America. I think it's safe. The people who live next door to nuclear power plants in our country know they are safe and know that nuclear power plants make great neighbors to the communities they are in. This morning in our country, more than 14,600,000 men, women, and children woke up living 50 miles from a nuclear power plant. They're located in 65 counties, and there's 104 of them. Now, why would there be 104 of them if they're only in 65 counties? Because once they move into a community because the community welcomes them, or they forced their way into the community, and it's built, and the fears and the speculation disappears, the nuclear power plants become great neighbors, and the people love them and welcome the second nuclear power plant to be built there. That's why there's only 65 counties that have 104 plants. These power plants use enriched uranium as their fuel, for the most part. There has never been an injury or death in the United States due to the use of uranium or other nuclear fuels in a nuclear power plant. There are over 260 nuclear-powered vessels traveling in every coastal waterway in every port of significance, like New York, San Diego, Los Angeles, Norfolk, Virginia, Annapolis, Maryland, San Francisco. And those nuclear vessels have thousands and have had tens and tens of thousands of men and women on them in the 50 years or so of operation in our nuclear Navy fleet. There are 436 nuclear power plants in the world in operation. In France, a country the size of Texas, with 63 million people in it, powers its people 80% with nuclear power. 80% of the electricity comes from nuclear power plants in France. And these power plants are located all over the country and in urban population centers. The spent fuel from a nuclear power plant cannot be made into a bomb without a very large and very expensive reprocessing plant that can handle large quantities of highly radioactive materials that are dangerous. And that is why scientists believe that no nation would make bombs with power plant generated spent nuclear fuel. It's much easier and safer to make bombs out of other radioactive elements that are just as readily available. Unlike oil, gas, and coal power plants, the fuel in a nuclear power plant doesn't burn. In a process called fission, the enriched uranium changes from one element to another, and in the process heats up. The heat is used to boil water, which turns steam turbines to make electricity. The enriched uranium is placed inside a big metal pipe called a nuclear vessel. The vessel is a round, seamless, 21-inch diameter pipe, the walls of which are 8 inches thick. It's sometimes 2 to 3 stories tall. The vessel is surrounded by a steel and concrete shell that is located in a building that has a containment dome around it. And that containment dome is, at least in the case of Japan, located in yet another building. And those are the buildings we saw with the hydrogen explosions. Every nuclear power plant in the world today has what is known as a containment dome to protect the public from radioactivity inside a nuclear power plant. The containment dome is 4 feet thick, concrete, reinforced with 1.5 to 2 inch steel rebar. It's as solid as a rock. The U.S. government, in an effort to test how solid the containment dome was in the event of a terrorist attack, crushed a Phantom F-4 jet into a containment dome wall at 500 miles an hour. What do you think happened? The jet disintegrated into dust. The wall was untouched. And you can see this with your very own eyes on YouTube if you put in the search engine Phantom F-4 and the wall. Computer simulations by the United States government show that the largest jet crashing at the fastest possible speed still does not penetrate or damage the containment dome structure. The containment dome is there to contain radiation and to exclude the possibility of terrorists successfully attacking a nuclear power plant. As I mentioned earlier, the engineering in Japan, with the most massive earthquake and tsunami they've ever experienced, those containment domes are still in place. Now, much has been said about the subject of spent nuclear fuel. That's the fuel that comes out of the nuclear power plant. Before I talk about spent nuclear fuel, I want to talk about the nuclear fuel itself. And I want to comment on this because one of the objectors at the last hearing said they were afraid about bringing nuclear fuel in front of a school. What would happen? Well, I want to tell you something about nuclear fuel. Nuclear fuel is not radioactive. You could touch nuclear fuel before it goes into the vessel, the nuclear power plant, and it wouldn't hurt you one bit. There's no radiation that comes from nuclear fuel before it's put in the nuclear power plant. It's enriched uranium. It doesn't have a radioactive element to it. When it goes through the fission process, it splits up like an egg, and there's a yolk and a white. And those two components, when it splits, are radioactive, highly radioactive. But let me talk a little bit about the spent fuel. Spent fuel is not waste. It contains 95% of its original energy. Energy that can be reused if we allow it to be. Under current law, spent nuclear fuel from power plants needs to be stored in containers on site. But there are many people working today on changing the law to allow the reuse of spent nuclear power plant fuel. They reuse it in France, they reuse it in Russia, they reuse it in Japan, Canada, and other countries. On January 3rd of this year, the Chinese announced that it had figured out how to reuse spent nuclear fuel. And we can too, if we change our laws to allow it. And until those laws are changed, it'll be stored on site. Now, right when it comes out of a nuclear reactor, it's stored in large storage pools of water connected to the reactor building. The fuel is later removed from the pools and placed in storage canisters that are dry and sealed. These canisters are placed in large steel and concrete structures located at the power plants. The canisters are designed to withstand all natural disasters and hazards. The National Academy of Science states that these storage methods constitute a safe manner of storing spent fuel. Some spent fuel has, with special permission of the Nuclear Regulatory Commission, and after a significant period of cooling at the site, been shipped by truck and rail. And there's been over 3,000 shipments since this has started, going over 1.7 million miles without a single accident. The reason that was allowed by the Nuclear Regulatory Commission is because some of the power plants designed in the 1960s didn't realize they'd be storing spent fuel for 60 years. And so they couldn't physically store it on site. So the government allowed them to store it off-site. Spent fuel is shipped in massive shipping containers called shipping casks, weighing between 25 and 40 tons for shipping by truck, and 75 to 125 tons for shipping by rail. Some comments at the Planning Commission meeting stated that France is so afraid of its spent fuel that it ships all of it to Siberia in Russia for long-term storage. And then that's what happens to it. Well, I investigated after the Planning Commission meeting and found out what France does do with their spent nuclear fuel. Almost all of it, but not all of it, is stored at La Hague. Some of it is sent to Russia, but not because they don't want it. The Russians have a reprocessing plant that reprocesses France's spent nuclear fuel, and it's shipped right back to France for reuse. France is in the process of building its first nuclear reprocessing plant for spent nuclear fuel, and that plant will be online by the middle of next year. Long-term storage of unusable radioactive materials, and I'm not talking about spent nuclear fuel, I'm talking about a valve that was involved in the nuclear reactor that has radioactive material in it, but it isn't fuel itself. You have to do something with that kind of material. What the world has decided to do, and by the world I mean just about every country that has contemplated the use of the storage of radioactive materials that can't be reused, is to use deep geological formations. Formations formed millions of years ago to store this material. France will open its first deep geological formation in 2020. A village by the name of Bure, B-U-R-E, in France, has asked the French government to store that fuel in their deep geological formation. France has a rule, and I think the United States should have one similar to it, that says if you store this kind of material in deep geological formations, you need to be able to take it out for the next 100 years, because France believes they'll be able to pull the energy out of even that material with the technological developments that will take place in the next 100 years. In the United States, we've got the Yucca Mountain site that was designated for that. And as you may be aware, there's been a lot of political challenges to put into using the Yucca Mountain site. Let me make a comment about spent fuel. I was born 65 years ago. About 5 years after I was born, we had black and white televisions. Black and white televisions 60 years ago. I've got in my hand an Apple iPad. This little device has 26,000 photographs in it and 3,200 pictures. It's got my entire working calendar and contacts of everybody I deal with as a practical matter. It's got the ability to communicate with the internet. And if I had put a phone in it, I could have used it for a phone and taken pictures and sent them all over the world. That's the kind of technological change that occurred in yet 65 years. Now, we shouldn't think about energy production as an immediate thing or as a problem today that can't be solved tomorrow. I believe we can solve through great American ingenuity and engineering just about any problem that's going to arise with nuclear power.